Okay, so this is lesson 4-2, and it is writing equations in point-slope form. So up until this point, we've been using slope-intercept form, the y equals mx plus b. Now we're going to be using point-slope form, and it's this equation right here, or this formula. So go ahead and write this whole thing down. Y minus y1 equals m times x minus x1. Out beside it, I would put or write that this is point-slope form, because you're going to have to know the difference now. It may ask you to put it in point-slope form or slope-intercept form. So just like slope-intercept form, you were given a slope and the y-intercept. Now point-slope form, you're going to be given a point and your slope. It tells you what you're given or what to look for. So we, if you notice this y1 and x1, that's 1 point. That's the point x1, y1. And then m we know is our slope. Y and x are part of the equation, just like the y equals mx plus b. Okay, so now let's look at an actual example with some numbers. So it says using a slope and a point to write an equation. Write an equation in point-slope form of the line that passes through the point negative 8, 3 and has a slope of 1/4. So they go ahead and give us the information we need, point and slope. So you start out by writing your formula. It helps, I promise, because then all you have to do is replace things. So y minus y1 equals m times x minus x1. x1 and y1 is your point. This is x1. Here's your y1. Okay, so now y minus y1, that's a 3. So y minus 3 equals your slope, which was 1/4, times x minus x1. The x1 is negative 8. So it's x minus negative 8, which we all know two negatives make a positive, and that becomes x plus 8. We leave it like that because they told us to put it in point-slope form. So you leave it exactly like that. You don't solve for anything. So I'm going to have you go ahead and try some. I'm trying to remember how many problems we have total today. Go ahead and do both of these. That won't hurt. Try both of these, and then I will go over them with you. Okay, so we are putting these in point-slope form. So we need 1 point and our slope. So this first one, we already have the point and slope. So we're putting it in y minus y1 equals m times x minus x1 form. So we already have the point, so we plug it in for our x1, y1, and we're given slope. So y minus negative 1 equals negative 2 times x minus 3. Only thing, when we have y minus negative 1, that becomes plus, and that is your answer, because that's all we're doing on this one. So on the second one, same thing. Have y minus y1 equals m times x minus x1. And we can leave it like that, or y minus 0 doesn't mean anything, so we can drop that. And that's it. On example 2, now we're going to look at like a graph or just given 2 points to write an equation. So it says write an equation in slope-intercept form of the line shown. Well, that's exactly what we were just doing yesterday on our worksheet. We took these 2 points. We know how to find slope with them. It's your slope formula, which is y2 minus y1 over x2 minus x1. And we found slope. Then we used our y-intercept. Well, if you notice on this, we don't have the y-intercept. So we can use our point-slope form equation to set it up, and then we can actually from there turn it into slope-intercept form. To be honest, they kind of are interchangeable. One leads to the other. So let's look at that. We can find our slope from those 2 points, y2 minus y1 over x2 minus x1. And when they simplified that, they got negative 2. So slope is negative 2. And now is important on which point is your x1, y1 and x2, y2 because of how you did your slope. So we said y2 minus y1 right here. We said this was x2, y2. So that means this one is x1, y1. So that is the point I'm going to use. Okay, if I had set it up the other way for slope, then I would use the other point. It just depends on how you set it up for your slope. So 1, 2 is the point we're going to use. So here's my slope. Here's my point for point-slope form. So y minus y1 equals m times x minus x1. You'll have to memorize that. So then I'm going to plug in my numbers. So here's x, here's y. So y minus y1 equals m, our slope is -2, times x minus x1. Now, from here, if they had said put it in point-slope form, this would be my answer. But it said slope-intercept form. So all we do from here is we simplify and solve for y on this equation, because slope-intercept form is y equals mx plus b. So we distribute this 2. So y minus 2 equals -2x, and then -2 times -1 is +2, so plus 2. Then we add this 2 to both sides of the equation to solve for y. So that cancels. I'm left with y equals -2x, and then 2 plus 2 is 4. So that is our equation in slope-intercept form. And all of a sudden, the reason I paused just a second ago is I had a realization. I'm thinking about the next lesson, I believe, on it actually doesn't matter which point you use. You just have to use one of your points. They plugged in the other point, 3, -2, and still got the same answer. So I'm thinking about a lesson that we haven't done yet. So I apologize for that. So that means back up here, after you find your slope, you can use either point and plug it into your equation. Okay, but if it was slope-intercept, it would for sure have to be the one where x is 0, like we did yesterday. So hold on, let me get this. We're going to go ahead and look at example 3 before I have you try some problems. So let me erase my stuff. All right, so writing a linear function. So it says write a linear function f with values of f of 4 equals -2 and f of 8 equals 4. So just like the previous problem, those are points. So I take those points, that's the point when x is 4, y is -2. And when f is 8 or x is 8, y is 4. Those are points. 4, -2, 8, 4. You use those points to find your slope. See, they change it to 1.5. I guess you can do that. I would rather you simplify this to 3/2 and just leave it 3/2. But you can do 1.5. If you had to graph it later, it would be best to leave it as 3/2. But from that, we found slope, and then you can just use either of those points. So they used 8, 4 to put it in an equation. That's not our y-intercept, so we have to use point-slope form first. So y minus y1 equals m times x minus x1. So I have y minus 4 equals m times x minus x1. From this point, we solve for y. I can't get rid of this 4 until I get rid of these parentheses, so we distribute. Y minus 4 equals 1.5x minus 12, because 1.5 times 8 is 12. Then we can add 4. When we add 4 to both sides, we get y equals 1.5x, -12 plus 4 is -8, so -8. Then it is a function. That's the one thing, the only difference that you have to remember to go back and do is change y to f of x. There is our function. So on this one, remember on both of these, example 2 and 3, we were putting it in slope-intercept form, but we had to use point-slope form to get there. So what I'm going to do, let me just erase a little bit of this. I won't erase all of it. Okay. I want you to try all 3 of these, 3, 4, and 5. So it says write an equation in slope-intercept form of a line that passes through the given points. So all 3 of these, and then I'll go over them with you. Now we are writing in point-slope form. We're not doing Now we are doing slope-intercept form, not point-slope form. So we start out, though, with point-slope form. That's where it kind of starts to get a little confusing. So first of all, on number 3, they just give us 2 points. Remember, that is where we go back and first find our slope. So I'm going to go ahead and label these x1, y1, x2, y2. Slope, if you remember, is y2 minus y1 over x2 minus x1. So I have y2 minus y1 over x2 minus x1. 10 minus 4 is 6, 3 minus 1 is 2, 6 divided by 2 is 3. So my slope is 3. That's all we have found. Now for your point slope form, y minus y1 equals m times x minus x1. You already have your first point. So I have y minus y1 equals m, we just found that, it's 3, times x minus x1. From here, remember now we work it out and turn it into slope-intercept form. So I can distribute this 3. Y minus 4 equals 3x minus 3. Basically, we're solving for y. Add 4 to both sides. Y equals, I have 3x, negative 3 plus 4 is 1, plus 1. Now it is in slope-intercept form. Okay? Another one, we find our slope first. y2 minus y1 over x2 minus x1. When we have minus a negative, it becomes plus. Negative 4 plus 1 is negative 3. 8 plus 4 is 12. I can take a 3 out of both of those and get negative 1/4. Come back up, y minus y1 equals my slope times x minus x1. Anywhere you have two negatives becomes plus. Now I can distribute. Y plus 1 equals negative 1/4 x. It's a negative times a positive, and those 4s, it becomes minus 1. Now I subtract 1. We're just simplifying this. That's why we have to learn the point slope form and slope intercept form, because one turns into the other one. So I now have y equals, because that canceled, negative 1/4 x, negative 1 minus 1 more is negative 2. There is our equation. So then on number 5, it said write a linear function g with the values g of 2 equals 3 and g of 6 equals 5. If you remember with functions, those are points. They're saying when your x is 2, y is 3. When x is 6, y is 5. That's 2 points. We do the same thing. Just remember with functions, instead of y, we'll now say g of x. That's the only difference. So here's my 2 points. I'm going to plug them into my slope formula. y2 minus y1 over x2 minus x1. 5 minus 3 is 2. 6 minus 2 is 4. That is 1/2. Then I come back using my first point. Y minus 3 equals 1/2 times x minus 2. Distribute. Multiply that 1/2 in. Y minus 3 equals 1/2 x minus 1. 1/2 times 2 is just 1. Then add 3. I'm going to write it over here. Y equals 1/2 x. Negative 1 plus 3 is 2. But we're writing a function g. So final step, or you could have done this from the beginning. 1/2 x plus 2. That is our function. All right, example 4 says the student council is ordering customized foam hands to promote school spirit. The table shows the cost of ordering different numbers of foam hands. Can the situation be modeled by a linear equation? Explain. If possible, write a linear model that represents the cost as a function of the number of foam hands. So the first thing they ask us is, can it be a linear equation? So everything we've talked about so far in our previous chapters and stuff, for something to be linear or a linear equation, it has a constant. And we know constant is your rate of change or your slope. So what we do is we see if we can find slope. So any table that is written like this across, x is always the one on top, y is always the one on bottom. So from that, we see if we can find a slope. And our formula for slope is y2 minus y1 over x2 minus x1. So I'm going to say, okay, this is 1 point. This is my xy, xy. I'm going to use these 2 points and see. So that's what they're doing here. They're seeing if we get a constant over and over. So 46 minus 34, y2 minus y1 over x2 minus x1. When we do that, we get 6. So between these 2 points, my slope is 6. So what they then do is they say, okay, well, we checked these 2. Now let's check these 2. 2 more points. Okay, 58 minus 46, y2 minus y1 over x2 minus x1. and we get 6 again. Okay, so then they check for these 2 points, and then again for these 2. When they do that, they get 6 each time. So that means it is a linear equation because we got the same slope over and over again. Okay, so since we got 6 over and over again, then that is our slope or our constant rate of change. So that means we can write an equation out of it. So back up here when it says, if possible, write a linear model that represents it, that means write an equation. So we can use our point slope form because we now know our slope is 6. And we can just go back and use, if that'll go away, any one of these points, 434, 646, 858, 1070, or 1282. Use any one of those. So they chose to use the point 434, first one. So from that, we now have all we need for point slope form. 1 point, x1, y1, and your slope. So they used C and M, or excuse me, M is slope, C and N for X and Y because, let me scroll back up to the table. Remember, X is always the one on top, Y is the one on bottom. Y is cost, X is number of foam hands. So that's why they used C and N instead of X and Y. So you could still use X and Y, that's fine. So C minus C1, so that is Y minus Y1 equals M times X minus X1. Here's our point. So X1 is 34, Y1 is 34, X1 is 4. So it becomes C minus 34 equals our slope of 6 times N minus 4. Now, to actually get an equation is where we simplify that. So you distribute your 6n. C minus 34 equals 6n minus 6 times 4 is 24. Then you add that 34 across. When you add that, it's negative 24 plus 34, which is positive 10. So that cancels, and we get C equals 6n plus 10. So it does represent a linear function or equation, and this is that model. Okay, so I know that one is a little tougher. So you can go ahead and try this one on your own if you would like, or you can just go ahead and continue and watch me work it out, or the video that works out. I'm totally fine with either one, but you're going to try number 6, and it goes with this table. It's similar to the one we just did.
You pay an installation fee and a monthly fee for internet service. The table shows the total costs for different numbers of months. Can the situation be modeled by a linear equation? Explain. If possible, write a linear model that represents the total cost as a function of the number of months. To determine whether the data are linear, find the rate of change for consecutive data pairs in the table. The rate of change from 3 months to 6 months is given by the quantity 302 minus 176, divided by the quantity 6 minus 3, which equals 42. The rate of change from 6 months to 9 months is given by the quantity 428 minus 302, divided by the quantity 9 minus 6, which equals 42. And the rate of change from 9 months to 12 months is given by the quantity 554 minus 428, divided by the quantity 12 minus 9, which equals 42. Because the rate of change is constant, the data are linear. Let C be the cost in...
So, all he's doing there is plugging those in for a slope. Y2 minus Y1 over X2 minus X1. And he did it for each set or group. He did these two, and then these two, and we get the same number and over. That's our constant, so therefore that is our slope.
In dollars, and let N be the number of months. Note that the constant rate of change is the slope. Use the slope M, which equals 42, and a data pair in the table, to write an equation that represents the data. Use the point 176. Write an equation that represents the data in point slope form. Point slope form is given by C minus C1 equals M times the quantity N minus N1. Substituting 42 for M, 3 for N1, and 176 for C1 gives C minus 176 equals 42 times the quantity N minus 3. Next, use the distributive property. Because 42 times N equals 42N, and 42 times negative 3 equals negative 126, C minus 176 equals 42N minus 126. Next, add 176 to each side of the equation. Because negative 176 plus 176 equals 0, and negative 126 plus 176 equals 50, C equals 42N plus 50. Because the cost increases at a constant rate, the situation.
So right here is our answer.